Hello. Welcome to a quick tutorial session. In this video, we will see capabilities of the BMC Archive Image Copy functionality in Recovery Plus component of BMC IME Backup and Recovery for IMS product. Now we will see what is Archive Image Copy. The Archive Image Copy enables you to restore customer data from an old image copy, even though the database definition has changed since the time the image copy was taken. For example, if you have a problem recovering an old version of a HAL-DB, and if in the years since the backup was taken, the database has been repartitioned, and the old key ranges have been lost, Archive Image Copy utility is of immense help. You can also use this utility to create test data that can be easily deployed to multiple IBM IMS systems when each of these systems has the same set of databases with different dataset names. With automatic generation of DBRC definitions, MDA definitions and ID CAMS allocation members. It can be used to rapid build of production-grade development and/or test environments whenever needed. Now we will see how to create Archive Image Copy. User can make a request to create an Archive Image Copy using BMC's Recovery Plus utility. Archive Image Copy data set contains the Archive Image Copy itself and some other control information related to the DBDS or area being image copied. The Archive Image Copy data sets can be dynamically allocated using models. The Archive IC Resource data set contains environment-related information when the Archive Image Copy is created. This includes DBD definitions, database allocation definitions, exit programs like randomizer, partition selection routines, etc. All the recorded information will be automatically restored when the database is recovered later. Archive Directory Data Set, ARUDR, is a repository that records information about all the archive image copies created, their data set attributes, timestamp, and some other control blocks. There is a utility, ARUDoodle, which can be used to generate different reports from the archive directory. Now we will see how to recover Archive Image Copy. User requests to generate JCL to recover a database from an archive image copy. Recovery is done using BMC Archive IC Gen JCL utility. The Recovery Gen JCL process validates the control cards and verifies that all the resources are available for the recovery. It reads control blocks from Directory Dataset, ARUDR. The resource file is restored so that we can establish the same environment that existed when the archive image copy was created. Gen JCL process generates AIM-SPDS definition member, DBRC definition member, MDA definitions, and also generates a multi-step recovery JCL. This recovery JCL has step to allocate all the AIM-SPDS datasets if dynalock equals no. Step to register all the databases to DBRC. Step to recover the requested databases using archive image copies. Step to rebuild indexes using BMC's secondary index utility for IMS. Review and submit the JCL generated by Gen JCL process to generate all the required artifacts. Thus, you are able to generate all the artifacts required for recovering archive image copy taken in the past. Now we will demonstrate how to create archive image copy and how to recover the same. In the process, you will also see how it can build test environment for you. In this JCL, we are generating archive image copy to recover the databases requested through CA Group 02, 05, and 09. As shown in JCL, provide your ARU load library in steplib, IMS reslib, PSBlib, and DBDlib in your IMS-DD. AIM-SPDS for ID CAMS definitions. Mention your ARU directory dataset in ARUDR-DD. If you see control card provided in RSISON, type run archive IC is mentioned to request the BMC IME Recovery Plus utility to create archive image copy. Timestamp last pit CA in GLBL statement specifies to use the timestamp of the last pit CA for the CA groups recorded in the recons. RSR model keyword specifies a model name to be used for dynamic allocation of the resource file. The data set can be a PDS or a sequential file on DOSD or tape device. If a PDS is required, use the directory blocks keyword to specify the number of directory blocks. The resource data set contains all the DBD load modules from DBDlib, exit routines such as partition selection, routine, randomizer routine, and so on, used in the create archive IC execution. You can see archive image copy is requested for CA Group 02, 05, and 09. Now we will submit this job, which will generate archive image copy for requested databases. Once archive image copy creation job is completed, we can check sysprint of the archive one step. Search on string registration, you will see message, archive image copy registration process started. You will see logs generated in archive image copy generation process, like ARURSRDD resource file is allocated. 13 members copied successfully to the resource file. You see for all database archive image copy is recorded in the directory dataset. Requested CA group information is recorded in directory dataset. Resource file is also recorded in directory dataset. At the end you see message archive image copy registration process ended and timestamp shown is recorded in archive directory dataset. This is how you can create archive image copy and record all the information in resource file and directory dataset, which will be helpful in recovering archive image copy in next step. Archive image copy recovery is a two-step process. Step 1. Generate JCL to allocate, recover, and rebuild indexes for one or more databases. Step 2. Perform the actual recovery using the generated recovery JCL from the first step. Let's see JCL, which is used to generate the JCL required for the archive image copy recovery process and other artifacts like DBRC definitions, MDA definitions, ID-CAMS definitions, etc. It specifically targets the last recorded archive image copy for CA group 02, 05, and 09. Make sure to provide the ARU load library in the lib step. Mention the ARU directory dataset in the ARU dir DD. Ensure that you have a PDS library in the ARU JCL DD where all artifact members will be created. Now we will see which parameters to be used in ARU sys and control card for gen JCL process. Out RSR keyword. Here we need to specify the name of a model to be used for the data set where the resource file created during archive image copy create phase will be restored. Out AMS keyword. Specifies the name of a model to be used for the allocation of the output AMSDS library if the dynamic allocation option, Dynalock, Y, is chosen. The model must specify a PDS with a non-zero value for the directory blocks keyword. This library will contain the ID CAMS delete/define and allocate statements for the databases after applying the new name mask and other overrides for space, SMS info, and so on. For Dynalock, in, this keyword is not required. New name keyword specifies the new name of the recovered database data set as a mask string. To generate the new name for the recovered database, the archive IC recovery utility applies this mask to the DBRC registered DS name. This allows you to use the existing ID CAMS delete and define or allocate members for dynamic allocation during the archive IC recovery. This is very important keyword as this masking will help you to create set of artifacts with mask name. We can use gen JCL step multiple times with different masking to generate the definitions with different names. MBR keyword allows you to specify a prefix, up to 5 characters, to be used for the generated member names. The default value is $ARUR. This keyword is used to control the naming convention of the generated members. We are specifying timestamp, last IC, as we are executing gen JCL process for last recorded archive image copy. You can specify specific timestamp too as per your requirement. All required artifacts are created for requested CA groups 02, 05, and 09 as shown. Now we will submit this job. Once job is completed, we will review the job output. As you can see, job is ended with max CC is 0. We will check sysprint to review the output. In sysprint, you can see log messages as shown. Model generated for resource model. Model generated for AMS PDS model. Recovery request added for all databases requested. Recovery request with last IC timestamp is added for all the databases present in all CA group 02, 05, and 09 groups. Input resource file restored successfully so that the archived DBDs can be used in the DBRC utility for registering the databases and the secondary index utility. As we have specified Dynalock, Y, AMSDS members are created for all the DBDS, indexes, and ILDSs in the out AMS library as shown. At the end, you can see messages. DBRC init commands generated successfully. MDA definitions generated successfully. Archive recovery JCL generated successfully. Archive recovery gen JCL utility completed. RC equals 0. Do not modify the generated recovery JCL or control cards except for small changes, such as job name and job accounting. If you need to make changes, make them in the gen JCL step and rerun the gen JCL process. Any alteration to the generate recovery JCL or control cards might cause unpredictable results. Now we will review all the artifacts generated by gen JCL process in rfp.aru.jcl. RU40 at II member contains DBRC definitions for requested databases. RU40 at MM member contains MDA definitions for requested databases. RU40 at RR member, a multi-step recovery job. It performs actual recovery of archive image copies created earlier. We will see steps generated in this job. Init DB0 step. It uses ARU40 at II member and sysn to use DBRC definitions. DB recov step. In this step, actual recovery is done. As you see in this step, resource file is used in step lib, ARU directory library, and AMSDS library. SIRBLD step executes BMC secondary index utilities to rebuild primary, secondary indexes and ILDSES for HALDB for requested databases. Recon data set DD cards will be propagated to the generated archive IC recovery job steps as you see here from gen JCL job. Normally, these will be a new set of recon data sets where the recovered databases with the new names for the DBDS, index, and ILDS data sets will be defined. To recover databases and rebuild indexes, submit the generated JCL member ARU40 at RR. Open sysprint for DB recov step to check message logs. You can see messages that recovery request added with timestamp for all databases in CA group 02, 05, and 09. For each database, you will see message archive recovery started, archive IC input opened, total records, etc. At the end, you see message archive recovery complete. If you see bookprint in job log, you will find index details that have been built for the relevant databases. This is how you can generate an archive IC and recover it. You can also use these steps to quickly create your own test environment. Starting from the RSL 2401 release, you will also find managed ACB and DDL support for archived image copy functionality. Please refer to the BMC IMI Recovery Plus user guide documentation for more information. Thank you.